I'll be talking about alternations in Seediq and how they can contribute to our understanding of different theories of morphophonology. So, Tgdaya Seediq is a language where verb paradigms show extensive alternations. This makes it a good test case for comparing between different theories of morphophonology. So today I'm going to be arguing that there's evidence from Seediq which supports an approach where the input to morphophonology is a single surface allomorph. So we can begin by thinking about two different approaches to morphophonological analysis. The first one, which I'll just call the cobbled UR approach, is this classical approach that I think most of us are familiar with. So where URs, or underlying representations, preserve as many contrastive properties as possible. This means that if no single surface form is maximally informative, the resulting UR must cobble information from different parts of a paradigm. So this is what it will look like in Tonkawa. So we can see that in slot A of the paradigm, the first vowel of the stem surfaces, while in slot B of the paradigm, the second and third vowels surface. So crucially, there's no surface form where all three vowels are present. And the cobbled UR solution would be to take information about the first vowel from slot A and information about the other vowels from slot B to give the URs that we see in the rightmost column. And we can see that in this case, the URs don't correspond to any surface form. So under this approach, given the URs, the surface forms are completely derivable from exceptionless rules or constraints. So for example, just using this word to lick, given a UR in italic, we can easily derive slot A of the paradigm using rules of vowel deletion. So in contrast, there's this newer alternate approach put forth by Albright called the single surface base hypothesis. And under this approach, learners would designate a single slot or surface allomorph in the paradigm to be a so-called base. And this base serves as the input for morphophonology, much as the UR does in the classical theory. So for example, just going back to Tonkawa, if slot B were chosen to be the base, then the grammar would need some way of deriving slot A of the paradigm using a series of rules or constraints depending on what framework you're working in. So if all forms of a paradigm have undergone some kind of neutralization, as is the case with Tonkawa, then no base is going to work perfectly and rules or constraints won't necessarily have exceptions. However, there is growing evidence in support of this approach from areas such as historical change and child learning errors. So today I'm going to be comparing these two theories by looking at data from Tgdaya Seediq. Seediq is an Altaiolic language spoken in Taiwan, and the dialect I'm looking at is spoken primarily in Nantou. So the Tgdaya population is about 2,500, but the number of fluent speakers, actual speakers, is thought to be much less than that. So of interest to us today is the fact that all forms in the Seediq verb paradigm suffers from some kind of loss of contrasts. And this makes it a good test case for comparing between our two different approaches to morphophonology. So Seediq verbs are almost always inflected for tense aspect and or focus through both prefixation and suffixation. And there are significant alternations between the suffixed and non-suffixed forms of verb paradigms. So just note that today, for simplicity, all the examples I'll show compare the bare stems against the unsuffixed forms, where the bare stems represent all the non-suffixed forms. So there are various sources of morphophonological alternation in Seediq, and in the interest of time, I'll be talking about three of these. So pretonic vowel reduction, post-tonic vowel reduction, and final consonant neutralization. So first, with pretonic vowel reduction, so Seediq has a typical 5-vowel system. Stress is penultimate, so suffixation will always shift stress rightwards. And pretonically, all vowel contrasts are neutralized. So first, onsetless vowels will delete. This gives us alternations such as in 1a, where awak alternates with wakan, with a being deleted when it is pretonic in the suffixed form. Otherwise, vowels will assimilate to a following stressed vowel if the two are separated by a glottal stopper and h. So therefore, we have leing alternating with liingan. Otherwise, and this last process is the most common one, vowels will reduce to u. This gives us alternations such as kesa to kusaan, barah, purahan, and so on. And pretonic vowel reduction, in this case, results in a glossive contrast in the suffixed forms of the paradigm. Post-tonically, a similar but more restrictive process occurs where the mid-vowels reduce to U and closed syllables. So therefore, we can see in these examples, the stems all have contrastive final vowels in the suffix forms. However, all three are reduced to U when in post-tonic position in the isolation stem. And in this case, what we see is loss of contrast in the stem forms, or more broadly, the non-suffix forms of the paradigm. In addition, there's various processes of final consonant neutralization, and a subset of these are shown here. So PB and K neutralize to K. So we can see, for example, in 1A to C, these suffix forms have contrastive stem final consonants, but all of these are neutralized to K in the isolation stem when they are in final position. Similarly, in example 2, the affricate T and D all neutralize to T. So therefore, this means that given a stem, isolation stem that ends in T, this final consonant could either non-alternate, as in example 2A, or it could alternate with T or D when suffixed. In addition, engma and M neutralize to engma, giving us engma-M alternations. N and L neutralize to N, giving us NL alternations. And there's also alternations involving stem final G, but these are pretty complicated, and I won't discuss them here today. So just like with post-tonic vowel reduction, what we find in this case is a loss of contrast in the isolation stem forms. So overall, what we find is that all forms of a Seediq paradigm, both the stem and suffix, suffer from some kind of neutralization, and some verbs can undergo very extensive alternations. So for example, in the word to break, we see gerung alternating with gureman, with all the orange segments are alternating. So the cobbled UR solution to this would be to take information about this initial vowel from the stem form and information about the final vowels and consonant from the suffix form to cobble together this UR, which doesn't correspond to any surface form. In contrast, under the surface base approach, we would designate either a gerung or gureman to be the base, and then try to derive the other slots of the paradigm. So these two approaches crucially make different predictions about what a Seediq language learning child would do given incomplete data. In other words, they predict different kinds of reanalyses or learning errors. So under the cobbled UR approach, the UR is determined by either the stem or suffix form, whichever one happens to be available. So this means that in principle, reanalyses based on both directions will be plausible. In contrast, under the surface base approach, the reanalyses will always be projected from the designated base, and the resulting lexicon will have asymmetries in paradigm structure that reflect this. And exactly how this works, I think, will become clear in the following section. So in this section, I'm just going to go over some quantitative patterns in the Seediq lexicon and argue based on this data that suffix forms are highly predictable from the stems, but stems are not as predictable from the suffix forms. In other words, the stems are more informative. And this follows, I'll argue that this follows if Seediq speakers have identified the stem to be a base consistent with Albright's surface base hypothesis. So the data here will be based on a corpus of 340 verb paradigms taken from a combination of dictionary data and fieldwork with 3 Seediq speakers. So first, let's talk about predictability from the stem forms. So recall that these are the following sources of contrast neutralization in the stem forms. And today I'll just be talking about post-tonic vowel reduction and final consonant neutralization. So the question we want to ask is, can these neutralizations be somehow undone in a principled way, given just the stem form, based on statistical patterns of predictability in the data? So first, with post-tonic vowel alternations, recall that due to post-tonic vowel reduction, given a stem of the form CVCUC with a post-tonic U and a closed syllable, this U could surface as either E, O, or U when stressed in the suffix form. And in theory, this alternation should be idiosyncratic and unpredictable. However, what we find in the corpus is that the identity of the vowel is relatively predictable via a process I'll call vowel matching, where the stress vowel of the stem tends to match the stress vowel of the suffix form. For example, given potus with a stressed O, then the suffix form is most likely putosan. Given petus, the suffix form is most likely putesan. Otherwise, this post-tonic U tends to not alternate and will surface as U when stressed in the suffix form. So because of this pattern, a speaker could in principle predict with relatively high accuracy what a post-tonic U will surface as in the suffix form. And so here's what the data looks like, where we can, this table is comparing the stress vowel of the isolation stem on the y-x-axis against the stress vowel of the suffix forms, just in stems of the form CVCUC. So we can see that if the stress vowel of the stem is U, the stress vowel of the suffix form is also U. So this is the dark blue square here. In other words, given a stem putus, the suffix form is always putusan. Similarly, if the stress vowel of the isolation stem is A, then the stress vowel of the suffix form is most likely A. And while this pattern is not exceptionless, it is true for 80% of the relevant forms. So because of this vowel matching pattern, we can sort of undo the neutralization caused by post-tonic vowel alternations, given just the stems. Just as a note, the vowel O obeys this vowel matching pattern, but it's quite marginal in the lexicon. We see only 3 of these, just in the corpus that I have. So that was vowel alternations, and now we can talk about final consonant alternations. So recall that due to final consonant neutralization, these final t, k, n, and engma show the following alternations. So again, in principle, these alternations should be idiosyncratic and unpredictable from just given the stem. However, it turns out that final consonants tend to almost always or almost never alternate. This means that given a novel stem, a Seediq speaker could in principle predict whether or not a final segment will alternate or not with relatively high accuracy. So we can see how this works here. So these rows are organized by final consonant, and the purple bars indicate segments that have a preference for alternation, and then the yellow bars indicate the proportion of non-alternating segments. So you can see that on one end, consonants such as engma have a strong dispreference for alternation. So final engma will almost always show up as engma in the suffix form. Given something like pating, the suffix form will most likely be putingan. And this is true for 91% of the data. On the other end of the spectrum, we can see that final t has a strong preference for alternation, and when it does alternate, there's a strong preference for alternating with t. In other words, given a stem such as patits, the suffix form is most likely putitan, and this is true for 76% of the data. So again, because of this pattern, we can undo the effects of final consonant neutralization, not perfectly, but with fairly high accuracy. So just overall, isolation stems suffer from a loss of contrast due to post-tonic vowel reduction and final consonant neutralization. However, because of the statistical regularities in the data, we can predict these alternations with relatively high accuracy. So now we can ask about the other direction. So will suffix forms similarly perform as a good base? So with the suffix forms, we know that final consonants and vowels are completely predictable. However, the penultimate vowel of the stem is always neutralized due to pretonic vowel reduction. So for example, given something like putiman, we know for sure that the final consonant will neutralize the engma. However, it's in theory not possible to predict what this pretonic U will surface as when it becomes stressed in the isolation stem form. And what we actually find in the corpus is that compared to the neutralizing processes discussed so far, the patterns of predictability that would allow speakers to undo pretonic vowel reduction are much weaker. So we can see how this works in this table, where which compares the stress vowel of the suffix form, x-axis, against the stress vowel of the stem form. And in general, compared to the table we saw earlier with post-tonic vowel reduction, the correlation between the two are much weaker here. So for example, let's say the stress vowel of the suffix form is a, the stress vowel of the stem is most likely a. So given putasan, the most likely stem form is patas. However, even picking this most likely option, we only correctly predict 38% of the relevant forms. And in general, if we try to undo pretonic vowel reduction by picking the most likely option in this way, based on the statistical distributions and data, only 49% of the forms are correctly predicted. In other words, it's much harder to undo the effects of pretonic vowel reduction. In addition, pre-tonic vowel reduction affects more forms in the processes, which cause a loss of contrast in the stem. So all non-monosyllabic forms. So basically, with the suffix forms, they suffer from more neutralization that's harder to undo, so making them less informative. So in other words, there's this asymmetry in the informativeness of the stem versus suffix forms, where the stem forms are much more informative. So how exactly does this asymmetry support the single surface space hypothesis? Well, we can first assume a lexicon with a relatively symmetrical distribution of segments. And if one cell of the paradigm is selected as a base, in this case, the isolation stem, then the verb paradigms whose other cells are poorly predicted will be leveled. And as a result of this, the base will become more informative. And this process will repeat itself as making the base increasingly more informative. So in the case of Seediq, we see that the isolation stem is much more informative than the suffix forms. And this asymmetry is not just a result of phonological neutralization processes such as vowel reduction. And this suggests that restructuring from a stem base has likely happened. So in this following section, I'm going to just very briefly go over some rule-based modeling results, which quantifies this stem-suffix asymmetry. And I'm going to also show some modeling results against a simulated lexicon to provide some more evidence for a base-driven approach to Seediq. So the model I'm using, I'm going to really gloss over all the details of the implementation, but you're free to ask me in the Q&A if you're curious. So broadly speaking, it takes surface forms as an input and then attempts to derive the other slots of the paradigm using a system of rules. It's loosely based off of the minimal generalization learner for those of you who are interested. Crucially, this model has an explicit algorithm for quantifying the informativeness of bases. In particular, each stem suffix pair in the lexicon is assigned a score, which reflects how well the model predicts the output. And I'll first compare two models, one with a stem base, another with a suffix base, and see how they perform on my corpus of 340 items. So here are the modeling results. Where on the left-hand side are the results for the stem-based model, right-hand side is the suffix-based model, and the y-axis shows the scores. You can just see that the stem-based model assigns visibly much higher scores to the corpus, to the lexicon, compared to the suffix-based model, and this confirms the stem-suffix asymmetry. And then, there's, before I finish, there's just one more question to address. In particular, the stem form is a good base, in part because neutralized segments either almost always or almost never alternate. For example, final engma has a strong preference for non-alternation, while final t has a strong preference for alternation. So this could be due to restructuring, as I've discussed so far, or it could be an accidental effect of baseline phonotactic preferences. For example, final t strongly prefers to alternate with t, and this could be because there's a strong baseline phonotactic preference for t relative to t, leading to relatively more t's in the URs. So to sort of check whether this is the case, I tested my two surface-based models against a simulated lexicon. And in this lexicon, the rates of alternation are determined by the relative frequencies of sounds in the Seediq lexicon. So basically determined by baseline phonotactic preferences. So if the stem-based model performs equally well on the real and simulated data, this suggests that the stem suffix asymmetry is simply an accidental effect of phonotactic preferences. So here are the modeling results for the second round. We can see first on the right-hand side the results for the suffix-based model. It performs roughly equally the same on both the corpus in purple and the simulated lexicon in yellow. And it performs badly on both of them. In contrast, looking at the stem-based model on the left, we can see that it performs better on the corpus model, corpus data compared to the simulated lexicon. So this suggests that the relative informativeness of the base cannot just be completely explained by phonotactics. So in summary, we see that the non-suffix forms of the Seediq paradigm are much more informative than the suffix forms. And this asymmetry isn't just a result of phonotactic preferences. These results are unexpected under a cobbled UR approach because such an approach makes no predictions about the direction of restructuring. However, it's a natural outcome of the single surface base hypothesis, where restructuring from a base will necessarily exaggerate asymmetries in the data, making the stem base more and more informative. So yeah, the results so far are based on a relatively limited corpus of 340 items. So I'm looking for more evidence either in support of or disproving this base-driven approach. So with ongoing work right now, I'm doing some productivity testing to see if speakers in their synchronic grammar apply alternations as predicted by the surface-based hypothesis. And it would also be really helpful to have comparative historical data to see if there's direct evidence of restructuring in this direction. So I haven't had much luck finding such data so far, but would really appreciate any sort of resources if people know of any. So with that, thank you.
Thank you. Now we have 9 minutes for questions. The chat should be open, and you can indicate in the chat and that you have a question, and I'll call on you. Please remember to unmute yourself when you're asking the question. Or you can type in the question and I'll read for you. Okay, Andre has a comment. Please unmute yourself.
Yes.
Hello? Can you hear me?
So me or
I'm
my question.
Sorry, Andre.
Okay.
Yes. So my comment is about the post-tonic vowel alternations. You have E and O alternating to U, right?
Yeah.
But those have different historical sources. I'm not sure how much you know about this, but this is all the way from Paul Lee's reconstruction of Proto-Italic phonology, where E it comes from an earlier schwa vowel, which was completely merged with U in the final syllable. So it surfaces as a schwa in whenever the stem is suffixed, the root is suffixed. Whereas the O, I'm not sure specifically about Tgdaya, because for other Seediq dialects, people have different analyses of the vowel systems. For Truco, I've seen 4 vowel analyses. So the O must come later and have a different source. Also, you were talking about the historical, some historical sources. If you're interested in comparative data from Atayal, I could provide some.
Oh, okay. I think. Yeah, so I didn't know about the, I think, historical sources of A and E and O, so thank you very much for that. And yeah, I would be interested in any historical data, I think.
Okay, the next question goes to Huijuan.
Yeah, well, my question is concerned with the sources of the data that you use for your study. On slide 16, you indicated that, well, you consulted Vowel Matching 2014, but actually the paper contains data from Tgdaya rather than Seediq. So yeah, that's Tgdaya, that's different. So I'm afraid that whether you have mixed together the 2 different languages in your data.
I don't think I have, thank goodness. So this is taken, so this is taken from an online dictionary that has both Atayal and Seediq data, and there was no direct citation source for the dictionary, and this is the standard cited source, I think. And with the dictionary data that I got, I didn't specify this earlier, but I confirmed all of those words with my Seediq consultant.
Okay, it's just that the reference you gave on slide 16, that's a reference on Tgdaya. And actually there's an online dictionary on Seediq. And if you check that dictionary, there are many examples where, so for example, there are vowel, according to analysis, it will be the ER alternation, or I've checked, I found a lot of data there like U and E, and a lot of patterns that you haven't included in in your study. So you might want to consult the official indigenous language online dictionary to see, well, to find more data.
Yeah, I will do that. Thank you.
Thank you. The next question goes to Chris.
Oh, thanks. Can you hear me?
Yes.
Okay. Yeah. Thank you for the very interesting talk. I think the question I'm asking is maybe related to the next slide, or that would be the useful reference slide, or maybe not. You know, the one where you have the statistics about how predictable the suffix form is from the stem form. Is that the direction? You know,
is it?
If it ends in "t," then, you know, whatever, 80% of the time.
Oh, yes.
That it will be an underlying T. That one, yeah. So I think, unless I'm mistaken, and maybe you addressed this and I just didn't catch it because I'm slow, but given that learners/speakers are using this type of model that you suggest, does it not make predictions about how sound changes through sort of overgeneralizations will happen through time, right? And do you have evidence, maybe you said this and I just didn't catch it and you can just point me to it, but is there evidence that that's true? Like, so for example, do we have evidence that what we know to have been historically underlying, not an underlying T? Wait, how would this work? You see what I mean? You get what I'm saying, right? Okay, so is there evidence that the overgeneralization patterns and that therefore the change through time would kind of fit this model or not?
So that is part of ongoing work in progress, I guess, because just really, I think something I mentioned is haven't had much luck finding very extensive historical data available for like the Atayalic languages. So yeah, this model would predict, for example, that if, for example, a stem that originally had an Engma-M alternation would be leveled towards non-alternation, and so on. And there isn't a lot of data available. I have found isolated examples. So for example, let's see, just something like this. So, sorry, the wrong segment has been highlighted, but you can see that historically this stem has a final M.
Okay.
So, and then synchronically, and this is based on just data collected from my consultants, we see non-alternation. So the theory that I've discussed today would predict that if I have more data, reanalyses will have a strong tendency towards this direction.
Okay, cool. All right. Thanks.
Okay, and Andre has a comment on Chris's question in the chat. Any other questions? Evening.
Hi, thanks for your talk. So you kind of threw out the cobbled UR approach because you said that there was no directionality in I guess informativity, right? But I guess I didn't see anywhere whether you were able to get frequency counts. I don't know if that's possible. You might imagine that the base is just more frequent, and so it ends up being more informative because of that. And then the suffix form that you're looking at is less frequent, and so maybe despite cobbled URs looking symmetrical, maybe they do actually just take more from the more frequent form. So yeah, do you have any comments about that?
Well, so I guess in principle, reanalyses could be based on a variety of factors, including like usage frequency. And that is something I have considered, but unfortunately haven't been able to find frequency counts for Seediq. Yeah. So, well, in the case of Albright's theory, he suggests that the base is selected based on the principle of which one is more informative. So this due to both suffering from less neutralization and yeah, basically from suffering from less neutralization. And I think, and correct me if I'm wrong, so historically the I think pre-tonic vowel reduction happened before the other like post-tonic neutralization processes. So it's possible that at some point in the Seediq history where pre-tonic neutralization had taken place, the stem forms were at some point much more informative than the suffix forms, resulting in this type of restructuring. But
Okay,
yeah,
thank you very much.
Frequency counts would be helpful.
Thank you very much. That's all the time we have for this talk.